Okay, let us start with talking about hyperbolas. So just interrupt me if you need to, Simone. I don't mind trying again. But for my first part of my lesson, what I want to do is I want to imagine a point A, which is in quadrant 1. I want to imagine a point B in quadrant 2, a point C in quadrant 3, and a point D in quadrant 4. And I want to know about the signs of the X and Y's in this quadrant. So I want to suggest that X's are positive in this quadrant and Y's are positive. So if I had to make up a point, I could make up a point like 3, 2 for point A. I want to know for quadrant B, what are the signs going to be for a point like point B? Put it in the chat. X negative and Y positive. Yes. Okay. So this could be like -3 and 2, possibly, if I'm making something up. Okay. What about point C? What do I know about the signs for that? So in quadrant 3, both of those would be negative. So maybe if I was making up a point, it could be something like -3, -2. And then what about D? What about point D? What do I know about the signs of those coordinate pairs if you're in quadrant 4? So X must be positive and Y must be negative. So if I was giving you an example, it would say something like maybe like 3 - 2. So for hyperbolas, it's really important you know which quadrants have what signs for their kind of what I've been doing now. So I want to ask you another question. If I had to multiply, so let's get rid of this. If I had to multiply the X and Y together in quadrant 1, well, I'm going to tell you I would get a positive. If I had to multiply the X and Y together in quadrant 2, what sign would I get? So for B, what sign would I get if I multiplied X by Y? I would get negative. And what sign would I get if I multiplied for point C, the negative times the negative? I would get a positive. And what about D? What would I get if I multiplied the coordinates of point D together? I'd get negative. Okay. So it turns out that this is a really, really important idea for hyperbolas. And the reason is hyperbolas are really made by multiplying the X and Y coordinates together. So the most basic way of writing a hyperbola together is to write X times Y equals A. Now, that's not normally how they show it in class. They normally show it like in grade 10, they show it like this. But if you rewrite it and you understand it as X times Y equals A, then, that's what a hyperbola is when it's very, very basic. And the A is important because if the A is positive, it means my hyperbola needs to be in this quadrant and this quadrant. Why do you think if A is positive, do you think it would be in quadrant 1 and quadrant 3? What do you think my reasoning for that is? If A is positive, why would I be in quadrant 1 and 3? So let's go to who. So I see some students have their hands up. Are you wanting to give the answer? So Tulani, are you willing to give the answer? Is that hand up for that, or is it just up from earlier? I can ask you to unmute if hi Tulani, can you hear me? Yeah, maybe there was a bit of a thing there. So what I want to say is that if A is positive, you'd be in these quadrants because that's where hyperbolas are positive. And if A was negative, you would draw your hyperbolas in quadrants 2 and 4. Give me a thumbs up if that kind of makes sense to you, the idea that if your hyperbola, let's say, for example, we had y equals 4 over x, then that would have to be in these two quadrants. Whereas if I had this, those two. Okay, fantastic. So the basic ideas are in place for hyperbola. What quadrant are we going to be? Now, the other thing we need to know about is the standard form of a hyperbola. Now, the standard form of a hyperbola isn't just a over x. We also have a plus p and a plus q. Now, what do you think the plus p does to my basic hyperbola? Sipo, the reason it's positive in quadrant 3 is you have a negative times a negative, which gives you a positive. So if you look at this, we have -3 and -2. If you multiply them together, they would give +6, let's say. Okay. And Paul has said that it shifts it and it horizontal shifts. Yes, so x plus p is the horizontal shift. It shifts it left or right. What do you think the plus q does? So the plus q, let's go to Monica. Monica, what do you think the plus q does?
Yeah, I'm not answering the question that you asked, but
it's all right.
It's the asymptote. And then, isn't it x minus p?
Okay. You can sometimes, some teachers write it as x minus p. That's it can also be written like that. Yeah, it's not wrong. I have seen teachers write it in different ways. I think at the moment the common version is like this, but it's not wrong. Yeah.
Okay, sir.
Cool. Thanks for the question. Okay, now we're almost done with it. So the a value affects the shape, and the a value affects what quadrant you are in. The p value will shift things. Now, there's something else that's important about a hyperbola. Hyperbolas have things called asymptotes. So if let's say, for example, I'm drawing a hyperbola like this. It looks a bit like a banana on its side. It never crosses the x-axis and the y-axis if it's basic hyperbola. And so we call the x and y-axis the asymptotes. But often what happens is we take a basic hyperbola and we shift it, and that moves the asymptotes around. So I want to show you how to draw hyperbola from the beginning to the end. And then after we've done that, you are going to do it yourself. So let me go to this one over here, g of x. Let me show you the process for drawing a hyperbola. And then once I've shown you the process, you can do it yourself. So I say step 1. What quadrants is this hyperbola going to be in? And the number that I look at is this number over here. So what quadrants is this hyperbola going to be in? I'll tell you now, Bongani, a p shifts horizontally, but you're going to see it in a moment when I do this. If you watch this example, I'm going to reinforce everything. Okay, so what I do is I do a mini little tick just to make sure I know what quadrants I'm in. And the reason is there's a positive number here, so I must be in the quadrants that when I multiply together, I get positives. Okay, and here where step 2 is. The asymptotes for hyperbola, when they normally start on in life, are on the axes, but we have a horizontal shift and a vertical shift. So the new asymptote, and I'll show you now what this means, is going to be y equals 4, because the asymptote plus 4, this has shifted everything up by 4. Then the x asymptote, which used to be the x-axis, is now going to be x equals 8. And what I say to students is, if you want to know what the asymptote is for the x value, you say, what value of x will make this thing at the bottom 0? So if you put 8 minus 8, you get 0. That's why the asymptote must be x is 8. this is a horizontal shift of 8 units to the right, but I'll deal with that later. All I want to check is you understand how I did this. And in fact, I'm going to actually practice this a little bit with you first. So before I draw this graph, tell me what the asymptotes are for the second one over here. So what are the asymptotes for this hyperbola, just following the logic of what I've just told you? So y equals -3 is going to be the one asymptote for this, and x is going to be -1 is the asymptote for this hyperbola. So because you ask yourself what number plus 1 gives you 0, and it's -1. Let's do another one. What about f? If I ask you to find me the asymptotes of f, what are the asymptotes of f going to be? It's going to be y is -2 and x is -4. So the asymptotes basically start off in life on the actual axes. And what happened is, like in these graphs, the -2 has shifted the asymptote down, and the +4 has shifted the other asymptote across. But it's very easy to get the asymptotes. I think all of you are feeling more comfortable. So let's go back to the drawing of the graph. How is it -4? So Yazi, you ask yourself what value, when you add 4 to it, will give you 0. Or you could just say this. You could say x plus 4 is 0. So x must be -4. Does that help, Yazi? So let's go back to drawing our graphs. Now, I love myself a good recipe, a good set of steps that guide me. Now, when we draw graphs, what is the one thing that we all have to find? It's going to be the y-intercept and the x-intercept. Oh, what if there's a minus in front? Good question, Cass. Okay. In this scenario, if the minus isn't involved with the denominator, it doesn't come into play. So I will do examples later, but you can basically ignore, if you have a situation like, where is there a -1? Here's a minus is sitting in front. This minus has to do with the 4, but it doesn't have to do with the x plus 1. So you can basically just ignore it as far as the asymptotes go. All right, now, I want you to try and find the y-intercept the way that you know how to find the y-intercept, which is by making x 0. And then I want you to try and find the x-intercept by making y 0. And I want you to apply that to the function g. So go ahead and find me my y-intercept and find me my x-intercept. We have here. So we have y is 3. And then for the x-intercept, it's a little bit trickier. Although you can do it sort of by inspection, but you can also do it, I'll give you a bit more time for that. So the y-intercept is 3, but now what's the x-intercept going to be? So what I'm going to do is I'm going to move the -4 to that side, and then I'm going to multiply this by this, Now, some of you will have a shorter way of doing this, and I don't mind that. We get, actually, I'm going to bring the -4 across, so I get x, and that's minus 24 over -4, which is 6. I get 6. Now, the long way of doing it like I did is reliable, but it can take a little bit longer. The other way you could do this, if you like inspection, is you could say to yourself, look, I have to end up with this being -4, because -4 plus 4 will give me 0. So what number does x need to be so that the big red circle is -4? Well, I think this has to end up being -2 on the bottom, because 8 divided by -2 is -4, which means that x can just be 6, because 6 minus 8 is -2. Now, you don't have to do that. I just want to show you that you could do it by inspection if you feel comfortable doing it. So Fateko was asked, why did we get -4? The reason, Fateko, is that when the 4 comes across, it has to become a negative. And so then what I did was I moved this thing to here. Yeah, let's go to Owetu. Owetu, what's your question?
Hey sir, can you hear me clearly?
Loud and clear. Go for it.
Perfect.
I don't have an answer for that.
So
is there something else I can help with?
So you see that part where you said x minus 8, you put it to the other side. Why don't we just put 8? Why don't we put 8 to the other side rather than the x minus 8? Because they're basically like terms. Can't we do that?
Okay, so the bigger problem is we really want to get x by itself. So when I start this problem out, right? Step 1 was get x by itself. So what we normally do is we try and isolate the variable. And the thing that is causing this to be crowded is the +4. So that's why the 4 moved first. And now the problem is that this x is stuck at the bottom. And because the x is stuck at the bottom, to unstick it, I almost need to bring it across and then distribute it. Does that make a bit of sense?
Yeah, it makes sense. Is there another case of where we could like times both sides by x minus 8? Can we do that?
Oh yeah, okay, you could do that. So what you could do, I think what you're saying. So at this point here, you would do it. Let me see, because maybe this actually could be quicker. Let's have a look. So at this point, if I times both sides by x minus 8, I get -4 times x minus 8 equals 8. So you're right, but you get to the same, because when you times both sides by x minus 8, you have to have an x minus 8 over here. So you kind of get to the same place, but it's a good comment. Yeah.
Oh, okay. Thank you, sir. I appreciate it.
Pleasure. Thank you for the question. Often, I really do encourage us to ask questions because the dialogue is so helpful for everyone. And so you don't have to know what's going on to even ask a question, as long as you're pointing out your point of view and you're explaining it. It's super helpful. So please do keep those questions coming. All right. Now, how do I draw this? So the good news is the hard work is over, everyone. The time of easiness is here. So let me show you how we do this. We look at the asymptotes, y equals 4, x equals 8, and we put them on our Cartesian plane. So y equals 4, there it is. X equals 8. Let's say that it's, I'm just going to zoom in for a second here. X equals 8. Here it is. These are the asymptotes that you worked out. Give me a thumbs up if you follow how I drew those asymptotes there. I just want to make sure I haven't lost you before I do the graph now. It's almost like I'm defining the field. And now I've defined the field, we're going to go play in the field. Okay, so I've marked my lines out on the field. Where do you think my hyperbolas are going to be? Oh, look at step 1. Step 1 says I must be in quadrant 1 and 3, but the quadrants have slightly shifted. So there is the one part of the hyperbola, and here is the other part. Okay, I cannot, now I'm going to redo this. I cannot go across that line because it's an asymptote. So I'm going to undo that bit. And you get better at these hyperbolas the more you draw them. Now, if you look here, what do you think this dot is going to be? Well, it's going to be y equals what? Y equals 3. And the reason it's 3 is because you know you worked out the y-intercept. It's here. What is this value over here going to be? It's going to be a 6 because you worked out the intercept there. And what's the final step you have to do? You have to label the graph G. So if you want to draw a hyperbola, step 1, label what quadrants you're going to be in. Step 2, work out your asymptotes. Step 3, work out your intercepts. Step 4, draw the graph using the information you've got, including marking the field before you do it, and then making sure you're in the correct quadrants. Okay. Now, before I move any forward, I just want to have another vote. Thumbs up if you feel like you're following. Thumbs down if you feel unsure. Okay. Now, some of you might be saying, oh, sir, what about the axis of symmetry? We'll get to the axis of symmetry, I promise, in the next lesson. But for today, I want you to be so good at drawing hyperbola you get bored. So what we need to do is we are going to do another one. We're not going to do that one. We're going to do, let me shrink this one. I want everyone, you don't have to draw the graph. Actually, we can. There's enough time to do this. And we'll take our break after we've drawn this hyperbola. So I want you to do the 4-step process. I'm leaving the stuff up on the board for you to go. And I want you to try and draw this hyperbola for me. And then after you've done that, we will have a break. Pop your answers in the chat when you've feeling more comfortable? Or... Yes, important. So if you know the shape will come from this value, and if you don't have intercepts, I'll talk to you in the next lesson about how if you need extra points, you can put them in. But for today, you know where it's going to be, and so you just put the shape in there. Yes. Okay, so we get for those who are got your intercepts, you can start drawing your graph already. But let's have a look. What do we have? We have 2 times x plus 4 is 1. 2x plus 8 is 1. 2x is minus 7. X is minus 7 over 2. So let me get my lovely highlighter. X is minus 7 over 2 for the x-intercept, and the y-intercept is minus 1 3/4. Now, how do we draw our graph? Remember our game plan. I feel like a soccer coach today, but the game plan is important. Step 1, draw the lines on the field. Y equals minus 2, and x equals minus 4. And now I ask myself, in what quadrants am I going to be in? Well, the value over here, the 1, tells me that it has to be, let me get a different color here. It's going to have to be, there's going to be one graph that's moving like that. And then there's going to be another one. Now, x is negative, so that's fine. And y is also negative. You can kind of see that it looked like that. My scale isn't perfect. So I can probably, okay, look, it doesn't have to have a perfect scale here as long as I got negative. Now you notice that I've got over here, let me just do this one more time. I think I can probably do a better job. So here, oh goodness, not much better. But here are my 2 intercepts I should be labeling. And this should be minus 7 over 2, or if I use decimal, minus 3.5. And over here, I should have minus 1 3/4, or minus 1.75. And the name of my hyperbola is f. And is there anything else that I need to label at this point? No, that is it. Yeah, that is it. Now, if you want to find a point, let's say I want to find a point on this part of the graph, and sometimes they may say label an additional point. What I need to do is I just need to make sure I'm on the left-hand side of x equals minus 4. So what's on the left-hand side? Let's say the number x. So I want to ask you guys, what is the f of minus 5? Now, I'm just making something up now just to kind of extend the idea, but can you guys use function notation and work out what the f of minus 5 is for me? Don't worry, I'll give you some more tips in a lady about how to plot the graph in a moment. It does get easier the more you do it. But for now, if you just understand the steps, that's fine in the first half. And then we'll get better as we go. So what's the f of minus 5? Well, that would just be the same as doing this, which would basically give you minus 3. Let me rub this out for a second. So this would indeed be -3. So if you wanted to label another point on this graph, all I did was put -5 in here and I got out -3. And so I can always label this point -5, -3. And you could get any point you like by just subbing it into the equation. And then you can label another point if you need to. Give me a thumbs up if you understand what I'm doing there. I'm creating another point on the graph just in case the question says, label a point, make sure you label a point on each half of the graph. I could have put -6 in. Okay, a lot of you, I've lost you here. All I need to do, if I wanted to get a point on this side of the graph, I just need to make sure I'm to the left of x equals -4. So I just put a value in that's to the left of -4. So I could have chosen -5. I could have chosen -6. As long as I choose something, which is an x value from down here, I will get a point on the graph over here. Okay, don't worry, I'll go over that in the next lesson. But I think the main idea, let me ask another question, is if you understand the 4 main steps, give me a thumbs up now. If you feel confused about 4 main steps, give me a thumbs down now. That's all I really wanted to make sure that you guys in the first half were on board with. Fantastic. I promise by the end of the lesson, you'll know even more. But we need to have a break. We are human. And so humans need blood and oxygen. I don't know if you found a way to avoid such things, but I have not. So stand up on your feet. And I want you to just unwind, do something that relaxes you. I like to twirl around, but everyone's different. And maybe just roll your neck a few times. And then change direction. Okay, and then let us do some circles. And bigger ones. Look at me, I've got a shadow. And then change direction. Okay. And then just shake it out. So kick out your legs. Kick out your legs, kick out your arms, and shake them out. And just feel a bit more relaxed. Okay, and then let us do some heart rate stuff. So let us do some jumping jacks. We're just going to do 20 jumping jacks. So up and your feet out as well and down again. So let's do 20. 2, 3, 4, 6, 12, 17, 18, 19, 20. Okay. And let us do a little brain break. Today's brain break is taken from the cartoon Scooby-Doo. Let's see if you can do it. Yeah, where to? I see you have your hand up. Do you have a question? Or maybe your hand's just up from earlier on. Fateka will do 24 again next week. I like to mix it up a little bit. Try to keep you guessing. So you're right, the Scooby van is 8. So now the question is, how much is I think this is some sort of monster, I don't know. So 8 plus 8 times something. The monster is 9. And Tokozo says the monster is 9. Why, Yazi? Is it a bit tricky today? So 8 times 9, if I know my times tables, is 72. And then 8 plus 72, I agree. Tokozo, I agree with you. I think the monster is 9. So now we need to figure out how much Scooby-Doo is worth. I don't know if everyone knows these cartoons, but how much is a Scooby-Doo worth? Sonic and Owami are saying that this is 5. So 5 times 9 would be 45. Wait, is that right? Plus 9 is 54. Yes. So what is this final one going to be equal to? A Scooby-Doo plus a monster times the Scooby Van. Well, BODMath says that we have to do the 9 times 8 first, and the 9 times 8 is 72. So this bit here is 72. Let's just get that. So that's 72, and this is 5, which means the final answer is 77. Yes, well done, everyone. Oh, that was something different, yeah. This was definitely a bit tougher than the normal ones, but I liked it because it kind of got you thinking a bit more. I see Gabriel, Talani, Tapiwa, Pim, all agree. All right, everyone. I think that was a good brain break. We should feel revived. Okay, now let us take it up a notch in terms of the types of drawings we're doing here. So we're going to draw another hyperbola, and this time there is a minus sign in front. Now, another way of writing this is to write it like this. G of x is minus 5 over x plus 2. And that is probably helpful in realizing that the a value is minus 5. So I want everyone to go ahead and use the skills that you've learned so far, the 4-step process, and try and find all the working out, and then try and draw me the graph of minus 5 over x plus 2. And then I thought I saw a question. Owetu, how do you find the y-intercept? Whenever you want to find the y-intercept, you make x equal to 0. Yes. And Impor, your question is such a good one. The asymptote is going to be x is equal to 0 because the only number that will make this thing 0 is when x is 0. So you're quite correct, yes. Oh, I see Impor is using words like vertical asymptote and horizontal asymptote. I will point those out now when we do these. Now, what quadrants are we going to be in? We're actually going to be in this quadrant and this quadrant because the a value is negative. And then here, the horizontal asymptote is y is 2, and the vertical asymptote is x is 0. Okay, now here, there actually is no y-intercept. And the reason there is no y-intercept is we cannot make x equal to 0. So if I try to do this, that's not allowed because you can't have division by 0, so there is no y-intercept. It doesn't exist in this particular graph, and we'll see that shortly. But we can hopefully find an x-intercept. And the way we would do that is we just make y 0. Let me know in the chat what you think your x-intercept is going to be. So we get -2. I get okay, so I get as my x-intercept 5/2, or you could also write it as 2.5 if you want to put it into decimal. So now I want you to draw the graph for me. Y is equals 2. Now, here's the funny thing. If the line falls on the, so where is x equals 0? So x equals 0 is actually this line. Now, we do not, if the asymptote falls on the axes, you don't have to draw it again. So the only asymptote you have to draw is the horizontal one, which is y equals 2. The reason you don't have to draw the x to 0 is it's literally on the y-axis. So when you draw your field of play, you now have it divided up, but you have to ask yourself, A was negative this time, and so when I draw the graph, I have to have this like that, and then on this side, this goes like this. Notice how it doesn't cut the y-axis, hence that's why there is no y-intercept. Also notice when I draw these, and I think a lot of you don't, the reason you struggle is I know I'm never ever going to draw in this quadrant or this quadrant. So the moment I know I'm not allowed to draw where the two big red X's are, it forces my sort of banana type shape to sit over here. So just imagine that it's almost like those two quadrants are out of bounds. Once you know that, you kind of just get used to drawing like a little banana. It's like a little banana. And the last thing that we have to do is we have to label it. So this label over here is going to be 5/2 or 2.5 or 2.5. Make it 2.5. And then I also have to call it the graph G. And that's it. So that wasn't actually that exciting, but you know, sometimes graphs can't always be exciting. So I think we can do another one. Okay. Let us do, I'm going to do the graph J. So I want you to draw the hyperbola J for me. So go ahead, you know the process. I'll let you get started on that. Yeah, where to? What is your question? Let's unmute you. What is your question?
Yes, thank you. So can you please just go back? I've been like, okay,
No,
go to the previous question. Can you just go to the previous question? I've just had this thing stuck in my mind before that one as well.
Okay, let's have a look.
Before that.
Okay, let me quickly just move this up with me because I think Smart failed to zoom in. So I'll put that question again here. Oh, look.
Okay.
Let me just get everyone to write this down. Okay, everyone write down J so that you got it so that you can work on things. And then I'm going to move up all the way to. Yeah, what do you want to talk about? Which one?
You see your y-intercept, right? It says
on which question? F or G? On F or G?
Or the F for F. Yes.
Yeah,
for F.
yeah.
So see your y-intercept. You calculate it, right? So
yes.
yeah, it says -1 3/4, right?
Yeah.
When I punched it in my calculator, it gave me -7/4. I want to know how you got that answer.
Okay. So in terms of -7/4 is the same as -1 3/4. So it's what we call an equivalent fraction. So the main idea is that this is equivalent to this, and so you would have got full marks for that. It's just knowing it's equivalent. Yeah.
Oh,
Does that make
okay.
Yeah.
Yeah, it makes
Cool.
perfect sense. I was low-key freaking out. Thank you, sir.
No problem. Pleasure. Okay, let's go back to this one. So step 1 is knowing what quadrants I'm in. Seems like the x-intercept is always the hardest one to figure out. But just remember, for those of you who like inspection, ask yourself, in order to give 0, this whole thing needs to add up to -3. And what value of x will make this whole thing -3? That's like a quick way of doing it, but it's probably for the most of us, it's better to just, do it the longer way and just make sure we get it right. But just be aware, you can do it by inspection if that's so what do we have? We have then x should be -1 over -3, which is positive 1/3. So to draw this, we are just going to say y is 3, like that. And then we are going to say that x is 1, which is going to be here. So we're going to say x is 1 and y is 3. And which quadrants am I going to be in? Well, I'm going to be over here, and I am going to be over here. Notice how I cannot touch these quadrants over here. Right? Those are out of bounds because of the shape of my thing. And then I just label over here, this is going to be 1. And this over here is going to be 1/3. Sorry, I probably should zoom in a little bit so you get a better view here. So this is going to be 1/3. This is going to be 1. And the equation of this graph is the graph J. Okay. And I think that is enough for today. I think the goal for today was to be able to draw hyperbolas, also understand they're about multiplying the x and y coordinates together